Hey everybody, this is a video on solving literal equations. Before we get into what a literal equation is, I'd love for you to do this warm-up equation. I'd love for you to solve for p. This is a quadratic, so pay attention to inverse operations and the number of solutions. Go ahead and pause your screen and do that. I believe everybody's had time. Here's my answers. Make sure you got what I got. If you didn't get what I got, ask a question or ask your teacher a question. We'd love to help you out. All right, let's get into what exactly a literal equation is. All right, so I've got several examples here that I'll work through you. On the left side of your screen are some just traditional solve for this one variable that exists. But over there on the right side are what we call literal equations. These are things are equations that have multiple variables where we don't have actual numeric quantities because we don't know what each of those variables are. But we could still use all of our same algebraic properties and solving processes to try to get one of these variables by themselves or solve for that variable. So, if you just take a look at that first row up there, number one, what we would do is we would try to isolate x by subtracting 2 from both sides. And that would give us 3x is equal to 6. We would then divide both sides by 3, all doing inverse operations to get x by itself. And x would be equal to 2. That was no big deal. We could handle that. But when you start dealing with literal equations, it's a little bit trickier, or it might feel a little bit weird because you don't actually have numeric quantities, 6 divided by 3 or something like that. So it sometimes makes it a little bit strange because it's like you're writing out every single step and you're not actually simplifying anything. I'm going to walk you through an example, and hopefully you'll understand what we're doing here, that the math is not different, just the results are slightly different. Okay, so very similar. Notice that this equation, instead of a 2, we've got a y. Instead of an 8, we've got an m. All right, so let's see how that happens. Now, the goal here is to solve for x. So that means just like before, we want to get x by itself. So theoretically, the process is the exact same thing. We're going to subtract, doing reverse order of operations. We're going to subtract first, and then we're going to divide both sides to get rid of the multiplication. All right, so let's do that. We are going to first, again, try to get x by itself. So unadd y would be subtracting y, and I even wrote 2. Look at that. So we're going to do the inverse operation of adding y by subtracting y. Got to do that from both sides. Now, here's where it gets a little weird for some people. The result of this, y minus y, those cancel out because that goes to 0. 3x plus 0 is just 3x. But over here on the right side, I don't know what m is, and I don't know what y is. So m minus y isn't just some number. So what we have to actually write is m minus y. We know that if we knew those numbers, we could figure what m minus y was, but we don't know those numbers. So we have to leave it like this. Now, our next step to get x by itself is to get rid of that 3. Well, 3x is 3 times x. So the inverse of multiplying would be dividing. So we're going to divide, oh my goodness. Let's try that again. We're going to divide by 3 both sides. Okay, well, 3 divided by 3 is 1, and 1 times x is just x. And now we've got x by itself, which is awesome. Now, notice that we've got m minus y still don't know what that number is. So if we don't know what that number is, we don't know what that number divided by 3 is. So we have to just be satisfied writing m minus y over 3. We have to be satisfied with that expression. So this is where the difference with the literal comes in, because if I knew what m was, if I knew what y was, I could substitute and figure out what this is. But I don't, so I have to leave it just like this. This is something that you would use to try to, for formulas that we get for like area or volume or finding something with energy, things like that. And we might have to manipulate that equation to find a certain unknown with multiple variables. And this skill set helps us with that. So solving literal equations feels a little unsatisfying because you don't have an actual numerical answer, but this is x by itself. This is what x is equal to, and the only thing we're missing is what's m and what's y. Okay, let's do a couple more just to try to build some confidence. I'm going to clear out this area here. And we will try out this number 4 here. All right, so notice that 3, if this was our equation, we would multiply both sides by 5, and then we would subtract by 2, and then ultimately divide by 3. So that would be a 3-step equation. Get rid of the division, just so we can isolate that top part. Then we would subtract, and then we would divide. All right, well, we're going to do that same process over here with number 4. All right. So again, I want to get rid of the division. Don't like the division. Some of you have even learned about some cross multiplication. That's not necessary here. I mean, it works, but you don't have to worry about it. If you don't know what I'm talking about, that's okay. So we're going to get rid of the division first in an effort to try to isolate the top and just make that feel a little bit more normal. So how do we undivide? Well, we're going to multiply. We're going to multiply both sides by c. Okay, now this is where it could get a little bit weird, but on the left side, the c's are going to cancel because this is really like a c on the top, like a c over 1 type thing. And that top and that bottom, they cancel because they're inverse operations. Well, what's left over? 3x plus 1, or sorry, 3x plus y over 1, or just 3x plus y. The whole goal of multiplying both sides was to get rid of the division. Now over there on the right side, because we don't know what m is and we don't know what c is, we have to just write mc, or m times c. Okay, now still trying to solve for x. So I'm trying to get x by itself. Well, I got to do the reverse order of operations. So I'm going to subtract y from both sides, being very careful, remembering that I don't know what mc is. So I just have to be satisfied with mc minus y for right now. Now my final step, just like my previous problem, I've got to get rid of that 3 in front of the x. So 3x is multiply, so I need to divide both sides by 3. Now these 3's cancel out because 3 divided by 3 is 1, and 1 times x is just x. And then because I don't know what m, c, or y is, I can't divide. So I'm just going to have to be satisfied with this expression, mc minus y over 3. So that's how we're going to do it. Now, again, it feels a little bit strange because there's a bunch of letters running around in there, but the same math, same algebra. Trust your skills. Okay? Let's do a little bit more complicated one a little bit further down here. What about something like number 12? That looks difficult. Actually, let's do 10 and 12. Now we want to solve for x for both of these, so let's just focus on 10 for right now. All right, and we'll do all the work out here to the right. So right away, that fraction grabs my attention, and I don't like it. I'm not comfortable with it, but because the entire left side is not being divided by 3, it's just one piece, let's try to isolate that. So I'm going to first get rid of the subtraction so that I could just concentrate on the most complicated part of this problem. So I'm going to add 5y to both sides because that's the inverse. These guys cancel out, and I'm left with 4x divided by 3 is equal to 11w plus 5y. Now, I don't love that, but it's okay. All the math works out. Now I'm going to just try to deconstruct this fraction. I don't like the fraction, so how do I undivide by 3? I'm going to multiply by 3. Okay, multiply both sides. So everybody on this right side's got to get multiplied. So that means I'm going to end up having to distribute this when I simplify on my right side. So be careful about that. But my 3's cancel because multiplying and dividing are inverse operations and they work against each other and they cancel. So now I'm just left with the top, the 4x. And I'm going to go ahead and distribute that 3 to simplify on my right. So 33w plus 15y. All right. Remember, my goal is not solving for every variable. It's just solving for x, meaning just getting x by itself. So there's only one more step here. I need to get rid of that 4 out front. 4 jammed up next to x is 4 times x. So I need to divide to get rid of multiplication. Don't forget to divide everybody by 4. Everything got divided by 4 there. All right. My 4's cancel. And I'm left with x is equal to 33w plus 15y all over 4. And again, because I don't know what w is, because I don't know what y is, I don't get an actual quantity here. Thing to keep in mind here before I am completely done with this problem, I need to double check, can 33 be divided by 4? Can 15 be divided by 4? If both of those can't be divided by 4, then we don't divide any of them by 4. So 33 divided by 4 does not give us a whole number, so that's not going to simplify well for us. 15 divided by 4, also not a whole number. That's not going to simplify it for us. So we just have to be satisfied with what we've got here. So what is x? 33w plus 15y over 4. All right, one more example. Clear out some space here for us, just not to be distracted. We're still solving for x, but we've got some distribution and we've got variables on both sides that we're going to be trying to get the x's with the x's and the y's with the y's. So let's go ahead and distribute so that we don't have to deal with the parentheses anymore. That's going to give us 6x plus 8y, because we multiply, equals 4x plus 12y. All right, again, I'm solving for x. I want to get x by itself. You guys know from working with me, I like to send my variables to the side that keeps them positive, meaning whichever side has the most of that variable. So there's 6x's on the left, 4x's on the right, more x's on the left. So I'm going to start off by subtracting both sides by 4x, so I didn't get all the x's on the same side. 6x minus 4x is 2x plus 8y. We had nothing to change that. These canceled, and I'm left with 12y on the right. Now I want to get the y's together, so I need to unadd, which would be subtract. So I subtract 8y from both sides, and I get 2x is equal to 4y. All right, so I'm almost done. Remember, I'm solving for x, so I got to get rid of that 2 out front. Well, 2x is 2 times x. What's the inverse of multiplication? Division. Divide both sides by that 2. X is equal to 4 divided by 2, or 2y. So there we go. Okay, so there's a couple of examples to really help you with some literal equations. Keep practicing. That's the best way to do this. Ask questions if you need to, and good luck.